Advanced Algebra 2 students, these are your 10.1 notes. We're going into a new chapter. It's really cool mathematical topics that look at patterns and sequences and series. Very cool stuff. A bit of a change from what we've been studying, but stuff that's really cool as you move ahead. So let's get started with it right now. Our first section is sequences as functions, so we're kind of just looking at patterns today. Our job is to identify and evaluate both arithmetic. Yes, I said that right, arithmetic, and I know it's spelled the same as arithmetic, but it's arithmetic, and geometric sequences. All right, a sequence is a set of numbers in a particular order or pattern. Each number in a sequence is called a term. A sequence may be finite or infinite, finite being meaning that it ends, infinite obviously it doesn't. The first term in any sequence we can call a sub 1, the second term is a sub 2, and so on. All right, so we have some blanks to fill out. Here we go, n and blank each term, and this one is an arithmetic sequence. So an arithmetic sequence. In an arithmetic sequence, each term is defined by adding a constant d called the common difference. Okay, so what we're talking about here is each term has the same difference as the previous term. So you're either adding or subtracting the same thing every time. All right, but sometimes we have different patterns. Again, we're going to focus on two of them today, but the second one we're going to look at is a geometric sequence. Geometric sequence. And in a geometric sequence, each term is defined by multiplying the previous term by a constant value r called the common ratio. So arithmetic means you add or subtract the same thing each time. Geometric means you multiply by the same thing each time. All right, let's look at some examples of these. We're going to start with number one. It says determine if the sequence is arithmetic, and if so, find D, that common difference. Okay, so what really when we talk about it being arithmetic, all we're looking at is, do we have constant change? In other words, are we adding or subtracting the same thing each time? And if you look at this, we definitely see we do. The answer is yes, it's arithmetic. And the D value just means what are you adding or subtracting each time? That would be 6. Okay, same principles. If I look at number 2, I can see this one's moving downward. This goes -2, then -3. Okay, we already have a problem here. And -4. So there's clearly some type of pattern going on, but it's not an arithmetic sequence. So we just simply would say no. Okay, and then number 3. When you look at this one, yes, it has fractions. Sorry, kids, not sorry. All right, 5/12, 7/12, 3/4. You know, everything else is 12ths. Let's make that 9/12. Think of it that way. And then 11/12. And all of a sudden, when you look at that, you can see, hey, each time I'm adding 2/12, which 2/12 is exactly the same as 1/6. So we have a common difference of 1/6. For our next set of questions, our instructions are different than what we've seen on the others, but we'll work with it and see what's going on. So we're going to do some similar things though, in terms of, like it says, to find the next 4 terms in the arithmetic sequence. So this time they're telling us it's arithmetic. We don't have to figure that out. What I need to do is figure out what the common change is, the common difference. And so you can see it right here. It's +2, +2, +2. So the next 4 would of course be 11, 13, 15, and 17. Pretty simple to find the next 4. But we're going to do one additional thing, which is we're going to actually graph the sequence. So the way we're going to do this, we have 8 terms here. This is a sub 1 right here, all the way down to a sub 8. So I'm going to do 8 tick marks here. Each one represents one term. I'm not going to be perfect with this graph. I'm looking for general trends more than I am precision. And then I'm looking at, okay, so the largest number I have is 17, the smallest is 3. I might just count by like 5s, and I think that'll be reasonable for me to be able to sketch this graph. So there's 5, 10, 15, and 20. Down here, this would be like your first term, second term, and so on. All right, so the first term is at 3, and I mean, this is pretty basic stuff, right? Just sketch the point. Second term is at 5, third is at 7, fourth, 9, fifth term, we're at 11, then 13, then 15, then 17. Now this is a discrete graph. In other words, we're not going to connect these points. There's not an a sub 2.5 available to us. So that is the final look for this particular problem. All right, let's look at the next one. Same instructions. And again, what we're looking for is the d value, the common difference. This time it's -4. And so I know I'm going -4, -4, -4. So my next 4 terms would be -6, -10, -14, and -18. And again, I'm going to do a very similar graph. I'm just looking at the numbers that have been given to us, and we're going to just kind of sketch what those would look like. I think I got 8 there. 1, 2, 3, 4, 5, 6, 7, 8. The max value I see is 10. The minimum is -18. So again, maybe like going by fives might be appropriate here. When maybe a little farther, but that's all right. All right, so there's -5. That means down here we're at -20, and we've got enough. So again, I'm going to just kind of quickly sketch where these points would be. Our first point was at 10, and this time it's down to 6, and then to 2, and then -2, and the pattern continues. And 18. All right, so the graph looks something like that. Again, we can see that linear trend, which is what we would expect for an arithmetic sequence. For number 6, we're going to use a little creativity. Now, you'll see problems like this later where you'll actually use some formulas and things to find this, but we're going to think of it in a slightly different way for now and be a little creative with it, like I said. So here's what we know. The fifth term of an arithmetic sequence, so I'm going to just go ahead and write it, a sub 5 is equal to 7, and we know the 10th term of the arithmetic sequence is 22. We want to find the 17th term. So here's my suggestion. We know it's arithmetic. That's important knowledge. That lets us realize, like, hey, this looks like a line. Therefore, we could find essentially a slope, right? And so if we were to think about it in terms of slope, we could do 22 minus 7 divided by 10 minus 5, and that would be 15 divided by 5, or just simply 3. All right, so we know the slope is 3, 15/5. That means that every step is exactly 3 higher than the previous term. So if I'm going to a sub 17, I'm essentially saying, well, that's 7 steps past a sub 10, right? And if I go 7 steps past a sub 10, that means 21 more spaces, 21 because each number in the sequence increases by 3, so it's going to be 22 plus 21, which is 43. That's the 17th term. Okay, so using a little better notation here, a sub 17 is equal to 43. Again, we'll look at some formulaic ways we can do that as we move ahead, but for now we're going to use some logic and consider the concept of slope and how that would apply. So we've talked about arithmetic sequences up till now, but we're going to switch over to geometric. So remember, geometric means you're multiplying by the same thing each time. So the question here is, determine if the sequence is geometric. If so, find R. Now, I'm actually starting you off with a fairly complex one. So what I look at is 12 to -6. What do I multiply by? Well, 6 is half of 12, but there's a change of sign as well. So we're talking about -1/2. And if you notice, that pattern actually continues. We go to +3, and then -1.5. So yes, this is geometric, and our R value is negative 1/2. So we have a couple things going on that can throw you off if you're not careful. One of them is the R value feels like it's division because you're multiplying by a number less than 1. Also, we're alternating signs, so we know the R value has to be negative. Now, I think number 8 is the kind of question that can really get people if you're not careful. So again, we have to think about, in terms of multiplication, what's happening here. Here's the way I think about this. I know the difference between these numbers is 16. And 16 is 1/4 of 64. So I'm multiplying by 3/4. Now let's see if that holds true. 1/4 of 48 is 12 times 3 is 36. So again, we're multiplying by 3/4. 1/4 of 36 is 9. 9 times 3 is 27. Pattern holds true. So this is another yes. This time the R value is 3/4. If you thought we were starting you easy on this, you were wrong. All right. Next one, number 9. Again, we're looking at multiplication. All right, 3 to 6, that's times 2. 6 to 18 is times 3. And 18 to 72 is times 4. There's clearly a pattern, but that pattern is not a geometric sequence. By the way, one little minor thing that I noticed, I didn't put a multiplication symbol up here. I don't want that to confuse you. We're not talking about subtracting 1/2. We're multiplying by negative 1/2. All right, let's keep on keeping on. So for the next two, we've seen similar problems with arithmetic sequences. These are geometric, of course. What I need to do first is just find the R value, and I think we can see that pretty easily on number 10. We're multiplying by 2 each time. That means R is 2, and if you want to find the next 3 terms, we'd do 16, 32, and 64. Now in this case, I was given 4 terms. I added 3 more, so I'm going to graph 7 terms. So I'm going to put 7 tick marks here to represent the 7 terms. Now none of these numbers are negatives, even if you had the sequence go back to the left further, which it doesn't. This is the first term right here, 1. But this is not going to go down into quadrant 4, quadrant 3, anything down here. It's only going to be up above. So the first term is exactly 1. But here's the thing, I don't want to put 1 here. I want to look ahead and say, hey, I got to go all the way up to 64. So I don't know, maybe counting by 15s would probably do the trick. 15, there's 30, there's 45, there's 60. We're actually going to go slightly above that. And I'm just going to label these first ones. So 1 and 1. All right, that's going to be a little tough to be precise, but it's really close to the axis down here. The second term, again, just barely above it. Then 4, I mean, this is hardly moving, right? 8, we're finally up to like half a tick mark. Then all of a sudden the growth starts to be a little more noticeable. 16, 32 is going to be up here. 64 would be like up here. I think we've seen this kind of a graph before. Interesting stuff. All right, so there it is. That's the graph. It's a geometric sequence. All right, let's take a look at 11. This is kind of a funky one, but I'm going to ignore denominators. There's 7 all the way across, right? But if you look at numerators, we're multiplying by negative 1/2. We saw a sequence like that earlier, but here it is again. So that means my next 3 numbers would be 2/7, negative 1/7, and then the last one, if you do 1/7 times 1/2, that's 1/14. So everything is sevenths until we get to our 7th term out there. So again, we're going to sketch this graph. We're not looking for precision on these. We're just looking to get an idea of what shape this graph takes. And this is a really interesting graph. All right, 32/7 is our largest number. Well, that's just a little below 5. I'm just going to count by ones on this one. 1, 2, 3, 4, 5. And I can go down the same steps. So this is -1, this is +1, and this right here would be my first term. So the first term we know is 32/7. It's just a hair below 5. There we go. All right, negative 16 sevenths. That's a little bit below negative 2. 8 sevenths is our third term. That's just slightly more than 1. Negative 4 sevenths is like about a half, a negative 1 half. And then what's happening is then 2 sevenths, then negative 1 seventh. We keep getting closer and closer to the x-axis. The further right we go, the closer to the x-axis we go. But it alternates sides. It goes above, below, and so on. Kind of an interesting graph. Again, definitely don't want to connect the dots. Just leave it as a discrete graph. All right, we've reached the last 3 problems on our notes today. We're going to look at these sequences that are given to us and determine if they're arithmetic, geometric, or perhaps neither of those would be an option. So let's take a look at this. So the first thing you might want to check is like, okay, so how much are we subtracting? Well, that's minus 125, and then that one's minus 100. Okay, that tells me something. We do not have constant change, which means it's not arithmetic. Let's figure out what would happen if we thought of it as possibly a geometric sequence instead. What would be going on? Well, the change here was 125. That's 1/5 of 625. So we multiplied by 4/5. I know for some of you that's messing with your heads right now, but trust me, it's 4/5. Hey, 500 to 400, that's also times 4/5, because 1/5 of 500 is 100 times 4, 400. 1/5 of 400 is 80 times 4 is 320. We just multiplied by 4/5 again. Folks, what we just found out is that is a geometric sequence. Okay, now it doesn't ask for this, but we know that the R value, the common ratio, is 4/5. Okay, let's look at our next sequence, number 13, 1, 4, 9, 16, and 25. You've probably seen this sequence of numbers before. But what you see here is the common difference doesn't exist. That's plus 3. That's plus 5. We've already kind of figured it out. There's not enough there. This is not arithmetic. Okay? It's not actually geometric either. If you look at it that way, 1 to 4 is times 4. But 4 times 4 is not 9. So it's not geometric. You know, I hope you know what this is. As a matter of fact, why don't you think about what it is and write on your notes where you've seen this sequence. But for us, it's not arithmetic, it's not geometric. We just simply mark it as a neither or neither, whichever you prefer. Okay, last one, number 14. Let's look at the pattern there. Again, I'm going to check and see if we have an arithmetic pattern going on. So I'm going from first term to second. I see that's plus 11. Second to third, I like what I'm seeing, plus 11. Third to fourth, plus 11. What kind of sequence is that? No, tell me. Yeah, okay, good. It's arithmetic. That's right. So we have an arithmetic sequence there. Folks, again, today's focus is looking at patterns of numbers, trying to distinguish what's going on. Or is it arithmetic? Is it geometric? Is it something else? Really good practice for you and your number sense. So I hope you enjoy what you do today, or even if you don't enjoy it, work through it, figure it out, think through it. It's good for you. And y'all have a lovely day.